I interrupted the last session because I could not decide which comes first, meaning you take a known equipment and try to analyze the things, or you start from scratch and try to build. So, both are absolutely valid. If you remember, I had shown this very early on, probably in the second or third lectures in this series, saying if you have to make something which is a handheld device, and if you want to convince your teammates on what we are building, you make a cardboard model. Finally, that is all that is related to this. And starting from there, in the lecture around 3 sessions back, I said all the hardware, the mechanical hardware which puts everything together also can be modeled, and you need to take the effort once. If you make the effort once of making a symmetric fastener, you can build a library. Same thing happens with all the other electromechanical other items. Now, have a look at this, the monitor, this slideshow here. I am sure you have all seen this type of small multimeters. Nothing great, or rather nothing, I will not say nothing great, obviously it is very, very great. The amount of thought that has gone into making it, it is really, really tremendous. But then the whole thing is available for almost nothing. You can get a probably beautiful multimeter for 200 rupees, that will come to some few $3 or $4. So, if you see carefully, there is nothing sanctimonious about it. This one has soft corners. This one, while in general, no, this is a squarish or rectangular thing. This one has a small waist here. So, one needs to work on all these things as we like. You see, very early motors, this one had something like this, and then we had this. Now, as we improve things, see what has happened here. Suddenly, it seems to have this dial-like thing which we can only see in music players. Music players had this, no. So, as things progress, all the necessary hardware and all changes. So, what started was a switch, and later on integrated with the printed circuit board contacts. Eventually, you just have a jog dial or some dial like thing which you are likely to find in a music player. This is where you continue to make various types of models. And why this model thing is required is, you see here suddenly we seem to have a very colorful presentation here, and what we are all familiar with this. One thing we are very, very familiar is that we have a dial, and then it has calibrations, and the moment you call it auto ranging, we have a little problem of trying to look at it. See what they have done, they have also put a beautiful a scale, and what looks a little like a linear thing. So, you know in this whole thing where you are, if you want you can be here, or your whole range can be there, and suddenly this does not, this is no longer a range switch. This is not related to the range, it is related to the particular parameter you are measuring. So, we have something with the usual amps, milliamps, volts, and at the other end we also have capacitance, we have the gain, then we have the temperature and certain logic thing. Now, all of them can be happily integrated into it. Now, before starting on this, you need to make a very, very simple, I will call it a pre-alpha model. Now, you see here other options, none of them have really caught on, but just these were existing about maybe 40 years back, we were existing. Occasionally these units continue to exist in the field when somebody has to climb a tower and then take measurements and all, you have everything. But the commonality between that and this is, you have a display and then you have a range also, same thing, a display, range, and you can tilt the what you call display to suit your things. So, I just thought I will show you all these things, and we are all familiar with it. Now, this is where you come to the next level, saying can you enhance the product by giving small features like this. In this case, the probes are attached to this. And you see here suddenly why I picked, this seems to be a very irregular analog meter. We have an analog meter and then we have a LCD digital display. It does make sense. So, at least you know whether you are here or anything. Afterward, further things you can read here. I am sure you would have had this problem if you have a small printed circuit board and you wanted to use a 10-turn potentiometer and then try to trim the voltage. And any electronic, this type of device will take time to measure and display. So, even if it is a matter of few 20 to 50 millisecond, 100 milliseconds, it will be very confusing for you to watch the display. Instead, you can always follow this meter, see here, and after that read the display for fine adjustment. And I think you can, you can stop the video at this point and observe what these are, including I think you will see what this is and then you will see what these are. You have so many of these things attached to that. We have a display problem, hence it has dropped off, do not worry too much about it. And fantastic things. Now, the moment the electronic display has come, you can do anything with it. They are even small, what look like oscilloscope displays. There is nothing oscillating, there is nothing scope about it. It has a display which shows various things on it. From here onwards, I do not think I need to go too much into this, but you will notice that when you want to make a device like a keyboard, there is no point in trying to make a 3D model out of it, because it is going to be expensive. All you need to do is probably take a printout on a A3 sheet and then see which best layout will come. Later on, that can be that A3 sheet what you are taking can probably paste it on top of a thermocol, a styrofoam sheet, and try to make all these things. Mind you, at this stage it really did not take off as well as we thought. Finally, the good old QWERTY keyboard is quite popular, it has come to stay. And see what is a fixed keyboard here, somebody has decided why not keep a hinge there and why not we break it into two parts. It really did not take off. These things do exist, somehow they did not take off. I do not know whether these are only concepts or anything, because both the mechanism and those things have become ridiculously complex. So, with this we have this problem of various things. Now, you see here we come to what I was telling you at that time. Most likely this is just a print. You can take this print and do what you want with it, and eventually you can make the mechanical part of it. Oh, something looks normal, but you can, for those people who are familiar with this other 3-dimensional devices, things like this can be done, but I will just call them a novelty, not even worth spending time on it. All these come vaguely, loosely under the concept of prototyping. Other thing here now, in reality design depends extremely on experimentation and study. Experimentation means not like a vague set up a physics experiment or a chemistry experiment or electronic experiments, saying think of various alternatives, see how well one of them fits best, and there are people who know how to evaluate these things, who have that little what is the immediate future where the technology is available, and then you can regroup the elements and try to make a better product. This is where the prototyping as we know it helps. Now, if you look at this, these all look very ancient. You have a, I think you know what it is. Things like the artificial horizon, things like the altimeter, and these are all probably very old pre-Second World War, just after the First World, early electronic revolution components look nice. Some things from here have changed, some things have not changed. If you see the voltmeter and ammeter and the graduation, we seem to enjoy it, we like it a lot. Since these things are very, very easy. Now, some other elements which I thought I will tell you is saying, in spite of there being a big thing saying voltage there, it is still repeated at the bottom. Okay. Similarly, here if you see certain designations, what we normally ignore is that all the stuff needs to be on top, so that in case you put something you can still see. So, we amps, we have cores, and then we have this on and off. See very carefully, here they have written power and on. There is usually a little problem with us in this part of the world, especially India and all that. They write power here, and it is conventional in India a switch, the bottom part of it the on. So, you end up with writing power then and on here, which is very, very confusing. And if you write power off and then you put on here, it is again one more time confusing. In contrast, at least for this, if you make this small jump and say write power on there and write off here, probably it makes sense. You understand, these small nuances can easily be done if you can make a simple cardboard prototype. Have a look at this. We know very well this is definitely not an equipment, but you see how well things have been laid out in this. This easily you can do on your screen. Any illustrated program will help, and the moment you take a printout and put it on a box and show it to somebody, people will be happy. This was long ago made probably for a CRO, cathode ray oscilloscope. Now, it is just a graphic display, and then whatever you want, you can have things here. And then now you see the small detail I was trying to tell you, there is a power on off switch and there is a green button which shows what it is saying. If you press it, the button will go on. This, I prefer this compared to the switch itself having a lighted switch. Is also possible. In some cases, the switch itself be a lighted switch, then things are little what you call crowded. So, one can go on like this. Just randomly I have taken a, I have just picked a few things from the internet. So, you have all known sort of things here. Oh, we have an element of something being disciplined, and I do not know whether we should call it a error or not. It is strictly not an error, but it would have probably made sense if you had put 50 ohm output here, same thing other outputs here, this designation on top would have, I would have preferred that, but then it is fine. These are all expected things work here. Now, as we go further, things have been very simplified at one level, meaning clutter is very less, but then a bit of learning is involved if you want to do this. You see here, a bit of learning, that is all, nothing great about it. Now, we come to the next thing. The moment you have switches and all that, now why do you need to write any designation at all? Why do you need to write anything here on this? Why can't the switch top itself have the designation? It makes sense to me. You have seen that nicely. The key top is engraved with the designation. So, there are advantages. The advantage being that you have saved lot of panel space. And this is where, coming back to my earlier solid modeling, if you somehow make this key top drawing and all part of it, you can always send all the keys for printing or engraving, or in the case of the first prototype, you can even print and stick it on top of it, which makes sense. Should it be on top? Should it be big? Should it be centrally aligned? Should it be left? And all this designations can easily be taken. See here. So, beautiful equipment, really tough. Now, just for demonstrating, I thought I will show you. We have a nice display here. The moment you have a display here, why can't we have directly touch screen? I am one of the people where my touch is not very good. It is either too harsh or too crude, and it does not work. Instead, it is now customary that you have regular tactile feedback switches here, which point to the thing. This switch points to whatever we are trying to display there, saying if you want to some ranging, it says if you want to do the ranging you press this. You see here nicely these things point towards it, so that you can change this and still the same switch holds good. And unlike the touch screen devices, you have a hard this thing and the display. This is where if you had just made a mock-up and show it to your colleagues, I am sure some of them would have said no, this is not needed, you can as well put a touch screen, and others would have voted out saying no, this seems to be better and let us leave it there. In that case you need not have any touch screen device here, you can just have a normal display and then your keys can be separate. Overall this may be slightly inexpensive compared to the other one, and this is what I was trying to tell you, saying where do you keep the key designation. So left top seems to be a default thing. These decisions are very important. It may not be too much important to a designer, and most users would have got used to it, which will where we come to stereotype. Stereotypical users are expected to know all these things. Things are getting better, small element of color and ruggedness. So this is an R&S, Roth and Schwarz device, which by definition are rugged. That is the only thing we can talk about. So we have so many of these things ready. So we have a beautiful device which does various things what you like, and I do not pity him. I am sure it is a challenge. I am sure you too would have loved to fly this device, but then you see what has happened. One small thing, all that automation, and then there is one I believe bypass switch which is hidden somewhere to take over manual control, and you know what has happened. So life is not that easy. While this is the little slightly older thing, you see here things been slightly improved now. Now they have various things which are there, still not as easy as we think. Things are improving. Actually because of our chroma key these things have fallen out, but there is a beautiful display also there. If you remember this, not long ago people were riding in the night without the thing. Now we have the artificial horizon, and then we have everything you want is already built into this. At this point probably I have exhausted what I wanted to tell you. I wanted to just stress on saying you need to make your own experiments, try to work on them. You see here this whole thing is just a simple mock-up. So I said shift top line, this is fine, and then you see here while it makes sense here is it not logical to make it there. So you can play with the colors, and what all I have spoken I have tried to put it here in this thing, so that first of all grouping of elements, and then the groups are supposed to be aesthetic or ergonomics or a matter of convenience. So if you ever look at all the light switches in any house, all the light switches we have everywhere, first thing you will notice is for a matter of convenience of the person who is making it and the thing, they put all modular switches in a row. So it is more like luck. If you can switch the first switch and then it switches everything, and since Murphy is active, most likely it will be the last switch. So it is not easy in certain cases directly from the common practice, not easy to group things. There it is a matter of convenience that they group everything in one place. So all the switches are in one place, but a few things are still attention is done. As soon as you open the door and enter, you expect that directly if you group in the open side up somewhere, somewhere the light switch for the room will be there, and it is now comes to how do we find out where it is like that. So obviously you can have a feedback, you can have a visual feedback Typically the visual feedback in those cases can be a neon lamp. So, if you see a neon glow, you will know very well it is there, otherwise it can be tactile. All other switches can be flush, that one switch switches on can be projecting out. And in the case of various types of what do you call new devices now, they will usually an auditory confirmation beep will be there. The confirmation beep will tell you that a value has been accepted or it is being changed. You have various things now where all we have to do, we have to do with displays, then we have to do with controls, and then various other things. Then here we have the population stereotypes. I am sure you would have noticed this a lot of times. If you want to increase volume, in the case of a volume, this is increase. Good, no? But in the case of any fluid flow, if you have a valve, it means decrease flow, okay, or shut, and this means open. Got it, no? Things like if you have a shower, if you have various things where there is a single valve, in general, if you turn anti-clockwise, you are opening the fluid flow. If you turn it clockwise, you are closing it. Now, the thing is, it will be a specious argument saying this, that and all, can't they learn and all? No, you are not expected to teach people to learn all these things. So, it is now accepted. Now, however, let us say there is not a multi-turn valve, it is just a quarter turn valve. You have seen that, no? The valves, gate valves with a handle, it will be clearly indicated in the gate valve. On the gate valve saying close this side and open this side. Now, we come to the next thing, saying occasionally if this is the gate valve, it is a water gate valve, this is the water going in, and let us say the water is flowing like this. Now comes the other thing, it's probably it's less logical, you put a lever here and show how to do it, and then this is going to be probably close, but you will find all of the things like that. Some of them this is open, this is close, some of them this is close and this is open. Why that is required is probably during maintenance or during the various other ways you need to maintain a traditional thing which is there, which is quite okay when you are in a small house by yourself, but if it is a huge dangerous plant which is making things, you need to follow certain norms. So, this is a typical exercise which I expect people to make. So, pick an equipment of your choice, like it could be a multimeter, a scope or a generator and everything, or this and all that, no, or combination of all this, and design a front panel for it. Design the whole equipment itself, but this was a control panel exercise saying, can you design something with it? Example, design a lab trainer. A lab trainer typically in the electronics lab, which will teach you what are all various things. One of the first point when to start is who will use it. Are they children who just finished their basic education and come back to the lab, or here no, matter of gender and semantics, what will she be using it for? So, if you have a lab trainer, what is the function of the lab trainer? What are the control displays, sequence, speed, precision, logical, safety? You have seen all this, no? After this, now this is taken from a known supplier, then you have something on top now. You have to make something which fits everything. Can we make it? that is the thing, saying this typically exercises which have been run, and so we expected the children to make all these things, and in the end they are very well off, absolutely no the problem. Once you do it, you will never forget these things. So, we have huge number of this material which I have kept here, and I think I have spent enough time to you about the whole series. The whole series is how to make a very simple prototype to do everything, but when you make it spend a lot of time and making the library of components, and typically the interface between the electronics, that is electronic design automation, and then mechanical solid modeling you can do in your own way, and as you gather the information or as you improve your thing, life is going to be very convenient just down the line. Maybe 6 months to 1 year you will be fully prepared to make anything you want. So, I will stop here, and then let me say this is the final handshake what you call lecture. So, I can say best of luck, and like all other thing, evaluation we still have something we have to work on it, but then the output what you do is you learn how to make these things. So, thank you, and I have 3 other courses which have been already uploaded. The first is about pure industrial design for electronic equipment, and typically it is about enclosure design. So, you can look it up in the NPTEL series. Then the second one is about thermal aspects, which were only demonstrating a few things like the heat sinks and how do you manage. The third one is about early rapid prototyping 3D printing meant exclusively for electronic equipment, that is small, typically in something which is not very big, and this one is about saying how to use your simple tabletop CAD and get started with the whole things. So, you need to collect a little information on existing things and then start, make a small cardboard model, present it to your what you call team, and if you do not have a team, if you yourself are the team, you need to work out with 2 things. That was the last example on the computer I showed you. I had a few keys, then I had a display, then the keys were arranged in a different format, and then the display is on top. If you now make these things, take them out and print them, or in your case if you are the sole person or anything, you can still use the rendering which is there on your screen and get started. Having that as a starting point, working inwards is easy compared to randomly placing things on a computer and now wondering where to place what, and you end up with a slightly suboptimal space. And so far the one what I am telling you, the thing is about a flat 2D illustration, but eventually if you make proper 3D solid models, you can also arrange things on your wherever it is inside. So, one of my students says he has actually a program which does what all I was talking to you about. It does all the front panel thing, it does everything, components, but what I have noticed is still related to arranging components for purposes of interconnection, not from the industrial design point of view or from the product design point of view. So, please take a start, make a start, and hopefully you will learn something. So, thank you. I hope you enjoyed the whole course. So, we will meet again. Thank you.